Hola, hi, this is Al, your statistics instructor. Let's get to work. In this video, we will do a couple of new things. Number one, we will be importing a text file into R. Okay? And the second thing will be learning a little bit about an alternative to histograms. We're going to be talking about kernel densities. Let's begin. Okay, so first we said that we're going to be learning how to import a text file into R. Okay, so the data set that we are going to be playing around with is this one. Okay, it has to do with long distance phone bills. This data set contains 200 observations. Okay. Now I have that text file available in my website, my personal website. But what we're going to be doing here is we are going to be saving that text file in a local folder, and then we're going to be reading it. We're going to be importing it from that local folder. Okay? Okay. So let me copy that URL. Okay, there you are. Okay, so that's the text file that we are going to be saving in a local folder. Okay, so now what we want to do is just save as, right? Then you go to a folder where you want to save it. In my case, I had already created that folder, sta258, right? And then, well, I'm going to be saving it there, right? So just save. Do you want to replace it? Yeah, let me replace it. There you are. Okay. So, now let's launch R. The first thing that you want to do, right, is we want to import that text file we just saved in that folder called statistics258 or sta258, right? So we have to let R know that we want to change something called the working directory. Okay, so we just go to the main menu right here, and we have this option, change working directory. So we go there, and in this case that folder sta258 is located here. Go to documents and then sta258, and there we have that text file that I had already saved, right? Okay, so that's going to be that folder, that local folder. sta258 will be our new working directory. Okay, so next step, we would like to import our data into R. Okay, so let me just use the following command. Okay, I'm going to be using the command read.table. Okay, read.table, and the syntax goes like this: file equals, and then the name of the file that you want. In our case, our file is called phone.txt. Now the first row doesn't contain an observation. It contains the name of the variable of interest. So in that case, we use that argument header equals true. That is going to be letting R know that the first row is not an observation. Okay, that guy contains the names of the variables in the data set. So we do that, and there we are, right? 200 observations. Okay, and as you can see, the first row contains the name of, in this case, the only variable contained in that text file. Okay, now let's do this again, but now let me assign that information to an object. Okay, and you know that you can assign, you can do assignments in R with the equals sign. So let me call this guy phone_data. Okay, now if we wanted to see the first few observations, we just have to do this. Head is going to give you, if I remember correctly, the first 6 observations in our data set. So just the syntax is head, open and close brackets, and then the name of your object of interest, in this case phone_data. So our first 6 observations. Okay, good. Now let's go back to our data set. I'm sorry, to our lecture notes, and just a reminder, we have dealt with histograms before. Okay, so the classes that I would like to use for this example are going to be defined like this, right? Those the limits for the bins, right, are going to be these. I want those bills to be the bins to summarize the information in the for the variable bills to go from 0 to 15, from 15 to 30, 30 to 45, and so on. Okay, now let me just show you something. If you type summary of in this case, first, you know that if you want to know the names of the variables in an object in R, you can use that command names. So in this case, the only variable contained in that object is bills, right? So now let me use the following command: attach phone_data. Okay, so now if I type just the name of that variable, in this case it's just one, right? If I just type the name, R will know that I am referring to that information, okay, to that variable. Okay, okay, now as I was saying, right, if we used this command summary and then bills, that is going to give you the minimum, the maximum, median, Q1 and Q3, right, first and third quartile, and also the mean, the sample mean, x bar, right? Okay. So since the minimum is 0 and the maximum is 119 point something, right, $119.60, that's why I decided to have those limits for the histogram from 0 to 120, and then the width for each of those bins, I want those to be 15, right? 0 to 15, 15 to 30, and so on up to 120. Okay, so let's try and make a histogram that satisfies that the width is 15. We know that the basic histogram in R using base R is just obtained using the command hist. Okay, so anyway, I have already prepared some R commands for you. Here we have used that command hist before, so the only thing here is that we are defining these classes, and something that might be new, I don't think we did that last time, is in this case, for this particular version of our histogram, we are going to be including the accounts for each of those bins that form our histogram. Okay? So if everything is okay, we should be able to just copy and paste these are commands from our lecture notes. So in this case, classes is a sequence that starts at 0 and ends at 120, and the distance between the elements of our sequence is going to be 15. So let's copy and paste that. So we have classes. It is exactly what we want. Okay, nice. Now hist we have used. This is going to help us create a histogram. This is an option, right? If we don't want to use that attach command, right, then this is what we have to do. We have to refer to the object and then $sign and isolate the variable that we are interested in this case bills. Okay, so now breaks, this is an argument for that function histogram, and then we're going to be creating a histogram with those with bins defined in this case by this object classes, so meaning from 0 to 15, 15 to 30, 30 to 45, and so on, right? This you have seen before is going to help us to make a blue histogram. This option here, right equals true, is telling R that the right end of these classes is included. Okay, so in the first class from 0 to 15 you will have observations that are greater than 0 and less than or equal to 15, the right end of that interval. Okay, and for the next one it would be observations between, well, greater than 15 and less than or equal to 30. Okay, that's what we mean by that right equals true. Okay, now this labels equals true, that is going to help us add those frequency counts for each of those bins, for each of those cells that form our histogram. This, I think we have seen before, is going to help us create a main title. That's going to be our main title, long distance phone bills. This X lab, we know it stands for the label for the X axis, and this guy here, Y lim, is going to help us modify the limits for the vertical axes. So in this case we want this guy to go from 0 to 80. So let me just copy paste. If everything is good, we should be getting something. Okay, makes sense. Now from that histogram, we know that we want to create those graphical representations of our data sets to be able to learn something about them. So in this case, something that we can say, we know that we have a total of 200 observations in this data set. So something that we can say is that about 1/2 of our data set, okay, lives between 0 and 30. Okay, so one could say that about half the monthly bills are relatively small, between 0 and $30. A few are between 30 and 75, and a relatively large number of them are going to be between 75 and 120. Another observation that we could make is that it seems that our variable bills, right, the distribution of bills seems to be the product of having basically here coexisting two subpopulations, right, that our customers could be divided into two subpopulations, two groups, one of light users and one of heavy users. Make sense? So anyway, that we can say just from from this graphical representation of our data. Okay. Now I just want to point out that you could do the same thing that we did here in R using RStudio. Okay, so let me launch RStudio. So in this case, if you wanted to change your working directory, you have to go here to Session and then Set Working Directory, and you want to choose that directory. We know that the one I want is sta258, and that guy is here. So I choose that guy, and now let me just copy what we had before, right? Okay, and let me now just copy this. It should work. Oh, I didn't define that object classes before, so let me do that. Let me copy and paste the R commands for our histogram. There, it's working. So as you can see, it's just a matter of what you like better, RStudio or R. Again, if you're using RStudio under the hood, you're using R. Okay, anyway, so Now the thing is, we said that the second objective of this video was talking about an alternative to a graphical representation, an alternative to histograms. We said we would like to talk about kernel densities. So you guys have dealt with probability density functions before, right? In sta258 you talked about, for instance, normal distributions, and we know that probability density functions, PDFs, are just formulas, and they have a graphical representation, right? We also talked about, for instance, gamma distributions, beta distributions, and all of them have their corresponding PDFs, probability density functions. Okay, and we could represent those probability density functions using a curve. Okay, so well, if we wanted to approximate the probability density function for the variable bills, we could use something called kernel densities. Those would be approximations to the density function of variable of interest. In this case, we would like to create an approximation for the probability density function of our variable bills. Okay, so that's what we're going to be doing next. Okay, just give you an alternative for a graphical representation. Instead of having something like a histogram, we're going to see a smooth curve. Okay, so let's do this using base R first. Let me use R because I think that it's going to be easier for you to see the commands that I type there. But as you can see, what I will do in R, you can use in RStudio. Okay, anyway, here we go. So let me create a density, a kernel density for our dataset bills. Okay. With this command density, I'm going to be creating that approximation for the probability density function of the variable bills. Okay. Now, what I'm going to be doing next is showing you what that approximation looks like. Okay. So let me do this plot in that density we just created. Let me just add a main title, and it's going to be just phone bills density plot. Okay. Yeah, that should work. Okay. Makes sense? So now what I'm going to be doing next is showing you on the same graph a histogram, our histogram, along with this approximation, this curve. Okay. So here we go. We know that to make a histogram we use that command hist, and then phone underscore data bills frequency false. This is important. Let me tell you why. Because now we are approximating those kernel densities are approximating a probability density function. So we don't want the frequency counts. We want we want relative frequencies because we want an approximation of the probability density function, right? Okay, so this is important. So you said that you set that argument frequency equal to false. Okay. Now let me modify the limits for the y-axis. I think these will work. And let me just add a main title, histogram plus density plot. Well, kernel density. Kernel density. Okay, so that is going to give us our histogram, right? But what we want here is to add on the same graph our density curve, this guy here. Okay, so to do that we're going to be using the command lines, then which is the name of that object, the one that contains the kernel density. Okay, now let me use color red. Okay, and let me make it I want a line that looks kind of not that I want something that looks with a wider. I want a wider line to be used. Okay, makes sense? Okay, so now just like you guys remember that you can modify the number of bins that you use for a histogram, right? So just like you can change the aspect of a histogram changing the number of bins, you can change the aspect of these kernel densities changing something called the band width. Okay, so now I think I have here a couple of other versions. So here what I did is I created a second density, one with a bandwidth of 6 and another one with a bandwidth of 24. And actually let me show you this guy here, the first one that we created, this one here. That should contain the original density, well, the original bandwidth. Okay, so 12. Okay, so the ones that I have here, one, as I said, is 6, the other one is 24. This command here, par and mf row, is going to help us create a matrix, if you will, of graphs, a matrix that contains one row and two columns. Okay, so we're going to have these two histograms along with the corresponding densities side by side. So let me just copy paste this. Okay, so can you see how the that number, the bandwidth, affects the aspect of that curve? And we're not going to be talking about the theory behind kernel densities in this course, but anyway, we just wanted you to have an idea that they exist, and an idea of you know, well, just to have more options to summarize graphically your data sets, not just histograms. Okay, and these may be appropriate when the random variable of interest could be considered continuous instead of discrete. Okay, So finally, let me just show you how you could do this using Gplot2, right? Because what we have done here is just using base R. Okay, so let's see how you could do this using Gplot2. Okay, so you know that let me just clear my console here. So you know that if you're going to be using Gplot2, that's an additional package, an additional R package. So every time that you're going to use it, well, you need that library. Okay, so let's load that library. So Gplot2. Okay, so now I have loaded that library. I have already installed before that R package. Okay, but that you have to do only once. But every time that you're going to be using ggplot for a particular session, you have to do this: load the library. Okay, so now we know that ggplot is going to be well, works with data frames. So let's create our a data frame for the variable of interest, in this case bills. So data frame, our guy is phone underscore data $sign bills. Okay, so we know that if we are going to make a graph using Gplot2, the first step is setting our canvas, right? Ggplot, and the syntax is: first you want your data, so that data frame we just created. Then the next argument is the mapping, right? So that with aesthetics is going to be is going to let ggplot know which well, which is going to be your x variable, which one is going to be your y variable. So in this case, we want bills to be on the horizontal, right? And on the vertical, in this case, what we want is density. That's what we want represented on the vertical axis. Okay, so density, and we know that if we do that, we're just setting the setting up the canvas. Okay, what happened here? Okay, no problem. I think we should be good. Let me see. Yeah, no problem. So now what we want is to add our density. Okay, so that argument alpha equals 0.5 is just going to control the transparency. Okay, and this guy call, as you have guessed, is going to be just the color for that density curve. Okay, make sense? Okay, now let's add another layer. Let's add the histogram. we know that with this argument call, we are saying, what we are asking R to do is we want the border of those bins to be black with fill. What we control is the color of those bins. In this case, I want them blue. And again, with alpha, what we're controlling is the transparency of those bins. And I want to use 0.5 again, right? Because I want you to be able to see that density curve, you know, and I don't want the bins to block that. Okay, so I think that should work. Okay, so that would be the default. When we talked about histograms and ggplot, you know that you can change the aspect of your histogram, right? You can change the number of bins, right? And you can also use the argument breaks to control exactly where you want these bins to be. Okay, anyway, but that's just you know, the basic graph that you would get, the default graph. You know that ggplot by default is going to use 30 bins here, right? So anyway, you could try an experiment changing the number of bins for your histogram. You could also try and change the bandwidth, just like we did with base R. But anyway, just wanted to show you how to do it with ggplot as well. You can play around with that using the options that we discussed before for histograms and using ggplot2. Okay, so let's summarize what we did here in this video. What we did here in this video was, first, we learned how to import data in a text file data from a local folder into R. Okay, then what we also learned is an option, another graphical representation for data sets, not just only histograms. Now we have at our disposal these curves, which are called kernel densities and are approximations to the probability density function of random variables of interest. In this case, our random variable of interest was bills, right? Long distance phone bills. Okay, well, that's it for now. Thank you so much for watching. Please take care and keep working hard. See you next time. Bye.